Does that clarify the question that you may have had? Yes? While we're here doing this problem, I want to show you something. Some of you may have seen this already, so if you have, just bear with me. What is x plus h to the 0 power? What's that equal to? It's equal to 1. I put the 1 right in the middle there, okay? What's x plus h to the first power? Just itself, right? X plus h. All right, what's x plus h squared? X squared plus 2xh plus h squared. So that's what you would get if you multiply them out FOILed, right? X plus h times x plus h. And then what's x plus h cubed? Well, that would be what I just put on the board a second ago. X cubed plus 3x squared h plus 3xh squared plus h cubed. What's x plus h to the 4th power? So that's x plus h times x plus h times x plus h, right? 4 times. Not many people know this one by heart. X squared plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the 4th. All right, I could keep going all day, okay, never stopping. The reason why is because there's a pattern. So first thing I want you to notice about these things is let's look at just the powers on x, okay, just the powers on x. Okay, what was the power up here? 0? Do I have any x's here? No. What was the power on x, on this x plus h here? 1? What was the first power that I had on the x? It was a 1, wasn't it? That was a 1 there. And what was the power on the h? A 1 also, right? Okay, look over here. X, the power here is x squared, isn't it? What did the x start with? X squared. What did the h start with? H squared. So move from left to right across here. I started x squared, then x to the first power, right? And then no x's. So you could almost say that the power on x starts at x squared and goes down, doesn't it? X squared, then x, then gone. And what about the h's? It's the opposite. There's no h's, right? There's no h, then there's one h, then it's h squared. Look at the 3rd row, or it's the 4th row. The power of 3. My x starts at cubed, then it goes squared, then it goes first power, and then there is no x, right? The h's backwards. No h, there's an h squared, there's an h cubed. So when you take an x plus h and you expand it, it starts out x, whatever the power is on the expansion, like this is 4, that's where we'll start. X 4, then 3, then 2, then 1, then gone. And the h's are backwards. Y'all see that pattern? Okay, so let me try the next expansion. See if you can help me out with this. X plus h to the 5th. What should I start with? X to the 5th plus, now don't worry about the number in front. What should the power on x here be? 4th. And what about the next one over here? What should the power on x be? 3rd. And then next one, squared, then x, and then the x will be gone, right? What about the h's? No h's on that first one, right? But then an h next to the x to the 4th, then an h squared next to this one, then an h cubed, then an h to the 4th, and then h to the 5th. Does everyone see that pattern? Okay. Now we just need to determine what we call the coefficients, the numbers. So to help you see the coefficients, I'm going to illustrate them. Here's 1, right? This was a 1 in front of both the x and the h. See the 1, 1 there? The next row was 1, 2, 1, wasn't it? 1, 2, 1. The next row was 1, 3, 3, 1. Do y'all see that? Okay, those numbers come from something called Pascal's triangle. All right? And so I'm going to just go to a quick, below this, just show you Pascal's triangle. Pascal's triangle goes like this. You start with the 1, and then each row, you have to have 1s on the ends, and each row has one more number in it than the row before it. So the first row has just the number 1. The second row has to have 2 numbers in it, but the ends always have to be 1s, so it has to be 1, 1. The third row has to have 1s on the end, but we need a number in the middle. And that number is the sum of these 2 numbers. What's 1 plus 1? 2, right? The next row has to have how many numbers in it? 4. The 2 ends are 1s. The 2 numbers that we need come from adding the 2 and the 1, and then the 2 and the 1, which gives me 3 and 3. Do y'all see how that is coming out? What would the next row be? Pascal's triangle. Pascal's triangle. So I need 1s on the end. How many numbers in between those? 3. So I get the first number from these 2, the second from these 2, the third from these 2. So it should be 4, 6, 4. The next row, I have 1s on the ends, and then we'll have what? 5, 10, 10, 5. 5, 10, 10, 5. And I could keep going, right? The next one would be 1, 6, 15, 20, 15, 6, 1. So when I come back up here, hopefully you see now that Pascal's triangle is in here, right? 4, 6, 4, 1. Do y'all see Pascal in there? So I should get here then what? 1, 5, 10, 10, 5, and then 1. So let's try one final piece then here. What's x plus h to the 6th? 1x to the 6th. Then what? Plus, careful, 6, because you're adding the 1 and the 5. So 6x to the 5th, h plus 15, x to the 4th, h squared, plus 20, x squared, h to the 4th, 6x, h to the 5th, plus h to the 6th. There, you can go show off to your friends now. Now, Pascal's triangle is one of those things in math where Pascal gets the credit for it, but the Chinese discovered it far before Pascal. So, you know, I don't know why he gets credit for it, but he does. Yeah, he didn't put the patent on it. All right, just wanted to show you that. It's going to come up later. I will say this though. Notice that, let's look at this last one, x this to the 6th. This is always this first power, right? And notice that this number is always that number also, like 5, 5, and 5, right? 4, 4, and then the coefficient is 4. 3 was the power, and then it's the coefficient. Ooh, that didn't work. But you see that? That'll come up today or tomorrow or on Wednesday. You'll see. All right. Let's get to what today is about now. We're going to do 1.5. So I'm hoping, again, that most of you watched the video. If you didn't, well, so I'm starting with an example. Continuity. In the little lectures that I put out there, when they discuss continuity, it basically means being able to draw it without picking up your pencil. And there were 3 types of discontinuities. Anyone remember what they are? Jump discontinuities, infinite discontinuity, and removable. Okay? Those are the 3 types of discontinuities. What about this first one right here? This is our first discontinuity. What happens there to our graph? It jumps, right? We're moving along the graph. We're moving, and then we have to pick up our pencil and then start drawing again. We have to jump from one point to the other, don't we? That's a jump discontinuity. All right, where's the next discontinuity? At this asymptote, right? Because if we're trying to draw, what happens? Our function goes up to infinity, right? And then on the other side, if we were trying to draw, it would go down to infinity. So there's no way to draw this without stopping and then starting it on the other side. But it's different than a jump discontinuity because what? Where's our function headed? To infinity. So we call those infinite discontinuities because your function is going to infinity. Y'all see the difference between the jump and the infinite? Okay, and then where's another discontinuity? I didn't label like 1, 2, 3, 4 for my x values. Where's my next discontinuity? At x equals 1, right? And what type of discontinuity is this? A jump again, right? So that's a jump discontinuity. Any other discontinuities? At x is 3. And what type of discontinuity is that? Removable. And it's removable because removable means that we could fix it real easily by just filling it in, filling in the dot, and then you would be able to draw it without picking up your pencil. But this question is not asking for you to do what I just asked you. It's saying to state the intervals where the function is continuous. That means tell me where the function behaves well, where you don't have to pick up your pencil. So where does it behave well? How about over here? Is our function behaving well over here? Yes. Until I get to where? X equals -3, then I have a problem, right? But after -3, I'm good until I get to what x value? -1. So let me try and start writing this out in interval notation. From -infinity to -3, I'm good, right? And remember, these are our x values that I'm writing. And then from where? -1 to -3, right? In between there? So the way I'd write this is -3 to -1. I have to write it from left to right. And what do we put in between intervals? Union. So far, does anyone have any questions on this part? I mean, I'm not done yet, but. So I have a discontinuity at -1, but what happens right after -1? My graph is nice and smooth, isn't it? Until I get to where? 1. So I should put union again from -1. Now, what do I put here? 1 with a bracket. Why do I put a bracket? Because it includes that point. And what, let's see who really took good notes and understands this. At -1, we would say this function is what? Y'all remember talking about me talking about left continuous and right continuous? As you come into -1, right?